We now learn the addition and multiplication theorem. First, we begin with addition theorem. If A and B are two events associated with sample space S, then the probability of occurrence of A or B is given by probability of A union B. So whenever there is union, we write, whenever there is OR, we write it as union. So this is nothing but probability of A plus probability of B minus probability of A intersection B, where this intersection is always read as N. Similarly, in the next case, if A, B, C are three events associated with sample space S, then the probability of occurrence of A, this OR is replaced by union. B, there is one more OR over here, this is replaced by union, and then there is C. Formula is simple, it is P of A plus P of B plus P of C minus P of A intersection B. Although if we write it as intersection, we read it as N minus P of P intersection C minus P of A intersection C plus P of A intersection B intersection C. Although this formula looks difficult, it is very easy to remember. Basically what you have to do is, in this case, you have to take all the singles with a plus sign. Whenever you take any pair, that means like A and B, A and B, then you take B and C, or you take A and C, you subtract all these pairs and you take all of them together, you again add them. Now we proceed, move with the multiplication theorem. If A and B are two events associated with sample space S, then the probability of occurrence of A and B. So in this case, we are interested in probability of A, and is nothing but intersection. And is nothing but intersection, and this probability is nothing but probability of A multiplied by probability of B, given that A has occurred. This part is called conditional probability. And in this case, the event A has occurred. It is the event A which has already occurred. Always in conditional probability, the down part is the event which has already occurred. Here, if A, B, C are three events associated with sample space, then the probability of occurrence of A, instead of this and we write intersection. B, instead of this and we again write intersection, and we put C, it is nothing but P of A multiplied by P of B, given that the first event has occurred, the event which is next to it has occurred, into probability of C, given that the other two events which are next to it, that is A and B, have occurred. See, we write this as intersection, but this only means N. This is the formula. Now, for independent event, the multiplication theorem has a slightly different formula. In case of independent events, multiplication theorem is slightly different formula. In case of independent events, the probability of A and B over here, which we write it as intersection, is nothing but P of A into P of B. Similarly, when A, B, C intersect independent event, probability of A and B and C is nothing but P of A into P of B into P of C. And now we solve some problems related to addition and multiplication theorem. The first problem is, a card is drawn from a pack of 52 cards. Find the probability that it is red or face. We solve this. So we want probability of the card being red, we denote it by red. This OR is replaced by union. and this is phase, so we denote it by F. So this is P of R by this formula. It is actually P of A union B is P of A plus P of B minus P of A intersection B. Now in place of A and B in this case, we have this R and we have F. So using the same idea, the formula for addition theorem is actually P of A union B is nothing but P of A plus P of B minus P of A intersection B. But in this case, where it is R instead of A and we have F. So this is P of R plus P of F minus P of R intersection F. Your P of R is nothing but the probability of getting a red card. Now, the number of favorable red is 5026 upon 52. P of R is what? How many number of favorable outcomes? That means what? How many cards are red upon the total number of cards. Similarly, P of face cards is what? We find out how many cards are face cards, and then we get this answer as 12 because you count in face cards, you count your king, queen and jack. There are 4 kings, there are 4 queens and 4 jacks. Total comes down to be 12 and total cards available are 52. And then we take what? We count those cards which are both red and face. Now, among these face cards, among these 4 kings, only 2 are red. Among these 4 queens, only 2 are red. Among these 4 jacks, only 2 are red. Total, we get the answer as 6 upon 52. So, when I say P of red and face, these are only 6 cards which are red as well as face cards. Therefore, we get it as 6 upon 52 with this minus sign. So, you get the answer as 26 plus 12 minus 6 upon 52, it is 32 upon 52. Similarly, now we solve the other part, that is probability of ace or spade. So this is probability of ace or spade. So this is actually probability of ace plus probability of spade minus probability of ace intersection spade. Now probability of ace is nothing but 4 upon 52 because there are only 4 aces and total cards are 52. Probability of spade is nothing but 13 upon 52 because 13 are favorable, and probability of ace and spade, although we write its intersection, it only means n, and we observe that this probability of ace and spade, there is only one ace which is also a spade, so therefore it is 1 upon 52. So you get this answer as 16 upon 52. You add, since both of them have the common denominator, you get 4 upon 13 minus 1 upon 52, which is 16 upon 52. Similarly, we do probability of the third question, which is king or queen. So probability of king or queen, this is actually equal to probability of king plus probability of queen minus probability of king intersection queen. Probability of king is what? There are 4 kings, total cards are 52. Probability of queen is there are 4 queens, total cards are 52. Now we want a card which is both king as well as a queen. This is not possible, therefore we write 0 upon 52. So we get 4 plus 4 minus 0 upon 52. We get the answer as 8 upon 52. We now solve another problem related to this addition multiplication theorem. It is observed that 60% read Navin times. That means the probability of Navin times is 60%, but we want probability, so we divide by 100 and we get it as 0.60. Similarly, probability of Gomantak times is 50 by 100, which is 0.50. Now, probability that they read both is what? They read Navin times, and although it is n Gomantak times, but in this symbolically it only means probability of n intersection G, and this is nothing but 30 upon 100, which is 0.30. We are interested in probability of either. That means what? Probability of Navin times or Gomantak times. So this symbolically only means n union G. This is actually equal to probability of n plus probability of G minus probability of n intersection G using the addition theorem. Now, using the addition theorem, because the addition theorem which we did earlier was the same one. It was P of A plus P of B minus P of A intersection B. So, your probability of Navin times is given as 0.60. Gomantak times over here is given as 0.50 minus probability of an intersection is given as 0.30. This will come down to, if you add all of this using a calculator, it will come down to 0.80. Now we are asked probability of neither. Now probability of neither is nothing but 1 minus probability of either. Now this probability what we have done is nothing but probability of either. That means what? Navin times or Gomantak times. So this is 1 minus 0.80, which comes down to 0.20. We now solve another problem. In a class of 80 students, 30 passed in mathematics, 20 passed in statistics, 10 passed in both the subjects. So now it is said that 30 passed in mathematics. So we'll find the probability. Probability of mathematics is nothing but 30 students passed. Total students are 80. So this is 30 upon 80, which is 3 by 8. Similarly, probability of statistics, you can also get this answer in decimal if you want. You can also find out this answer in decimal. Probability of statistics is 20 passed upon 80, which is 2 by 8. And then we say that probability that they passed in both. Now when it is both, it is said mathematics and statistics. Symbolically, it only means that the probability of mathematics intersection statistics, which is 10 upon 80, which we write it as 1 upon 8. Now we are asked, the first question is probability that he asked passed in both the subject. This is nothing but probability that he passed in mathematics and statistics. So that means probability of M intersection S, which we have already found it as 1 by 8. You can also get this answer in decimal if you want. The second will be that he passed in either of the subject. Now probability of either means that fellow has passed in mathematics or statistics. So that means the student has passed in mathematics union statistics. This by addition theorem is nothing but P of M, that is P of the first part, plus P of S, P of the second part, minus P of M. This union gets replaced by intersection. We are left with S. P of M we found it as 3 by 8. P of S we found it as 1 by 8. P of M intersection M we found it as, this is 2 by 8, 1 by 8. So we get it as 3 plus 2 minus 1 upon 8. We get the answer as 4 upon 8. Now we move to the next part, which is probability of the last part, that he has passed in none of the subject. This is same as saying probability of neither. That means none. So that means what? This is same as saying 1 minus probability of either. And this is nothing but 1 minus probability of either is what? We passed in mathematics or statistics. This is 4 by 8. So you insert 4 by 8 here. When you multiply 8 upon 8, 4 upon 8, you get 8 minus 4 upon 8. You get the answer as 4 upon 8. This is how you solve this problem. In short, the trick to remember this addition theorem is pretty simple. Probability of A union B is nothing but probability of the first part, whoever is first, plus probability of whoever is second, minus, you just change the, you keep A and B as it is, only thing, this union gets replaced by intersection. This is a way to remember the addition theorem. Whatever P of the first part, P of the second part, A and B as it is, only this union gets replaced by intersection. Now we move to the next part, next problem. Two cards are drawn from a well-shuffled deck of 52 cards. Find the probability that both are aces if the two cards are drawn one after the other with replacement, without replacement. Now, this problem is slightly complicated and doesn't look and it need not be solved in the way which we usually solve. Usually when two cards are drawn from 52 cards, we use the combination approach. That means we say 52C2, and now in this case if both are aces, what do? We say the answer would be 4C2 upon 52C2. But this we do when these two cards are drawn at once. The problem over here, the cards are drawn one after the other. This line is very important to change the approach of solving the problem. So this approach about combination will not help because here the cards are drawn one after the other, and therefore when two cards are drawn one after the other, they become separate events. That is, they are no more one event, they become separate event. So now we define A to be the event of getting first card as ace, first card ace, and B to be getting second card ace. Now we are asked what? If you observe in the first question, we are asked probability, find the probability that both aces. That means what? Probability that A, the first is ace and the second is also ace. We are asked both aces. That means what? The first card is ace, and second is also ace. So first card is ace is nothing but it is A. If you observe here, this is event A, and this is nothing but second card is ace is also here. This is B. So this is probability of A and B. Symbolically, it only means P of A intersection B. Now, to recollect, if you recollect, when we did multiplication theorem over here, we got a formula for P of A and B, which is nothing but P of A into P of B by A. We also, in independent event, we got another formula as P of A intersection B as P of A into P of B. So in short, whenever we want to find P of A intersection B, this we have to use either P of A into P of B by A, the one that is given by the multiplication theorem over here, or we have to use this independent event formula which says that P of A into P of B. Now which one we use depends totally on the question. Now in this case, we are asked probability of A intersection B. Now we are solving it for the first part. The first part says what? The first part says what? The cards are drawn with replacement. Now, cards are drawn with replacement. Now, now when we draw the cards with replacement, the what card you draw in the second case is independent of what card you draw in the first case. Because consider this simple example. I give you a pack of 52 cards. You take a card, see what card it is, you keep it back. You shuffle, I shuffle again, and I give you another card to remove. So in this case, your second card is independent of what card you remove first. Because what has happened is you have replaced that card back. That means what? Whatever card you removed first, you have kept it back. So which is why this P of A intersection B in this case becomes independent event, and we use the formula which we use for independent events. That is this one. So in this case, this is equal to P of A into P of B. For a simple reason, when you keep the card back, you replace the card which you take, your events become independent event. So your P of A in this case is probability of getting an ace, and this is nothing but 4 upon 52. If you observe here, your A is nothing but getting first ace. So it's like getting an ace. And this is nothing but there are 4 aces, total of 52. So you get 4 upon 52. Similarly, your P of B is what? Getting second ace. So this is also equal to, there are 4 upon 52. So this is how you get the answer as whatever is 16 upon 52 into 52. You multiply and get this answer. Now we do it without replacement. This also is what? Find the probability that both aces. That means what? The first has to be an ace and the second also has to be an ace. That is, we want P of A intersection P of B. Now, when you don't replace the card which you take and you take the second card, that means what? Suppose I offer you a pack of cards. You take a cards, you see it. Now you throw that card out. Now when I offer you another, the remaining pack of cards, whatever card you draw is dependent on what card you have drawn in the first case. For a simple reason, now in the second case, there is one card less because the card which was removed in the first attempt was not replaced, it was thrown out. So now you have one card less. So in this case, your second event or probability of getting the second card is dependent on what happened in the first case. So therefore, in this case, we use the dependent event formula for a simple reason. A and B are dependent, so we use this formula. This is P of A multiplied by P of B by A. Now P of A is what? Nothing but it is the probability of getting the first card ace, which is nothing but 4 upon 52, and we want probability of B by A. That means we want now the probability of getting B is what? If you observe here, B is second card ace, second ace. This line nothing but given that the A over here is nothing but the first ace, because given here A is nothing but the first ace. So this is nothing but 3 upon 51. For a simple reason, now you have to assume that in the first case, when you do P of B by A, you have to assume that the first card that you removed was already a ace. Now, You have to ask yourself what is the probability of getting a second ace when you know the first card was ace. So the card that you removed in the first attempt was an ace. So now when you want to draw another ace, there are only 3 aces which are left and total cards which are left are 51. Which is why you get the answer as 3 upon 51. Because you have to now assume that this second event A, that is the event A which is getting the first card as ace, has happened. That means in the first attempt whatever card you draw was an ace. Now when you draw a card in the second attempt, you have one ace less. At the same time you have one card less, therefore your probability of B by A becomes 3 by 51. So we insert 3 by 51. This becomes 12 upon 52 into 51. Now we solve the next problem. A problem is given to 3 students A,